is section 7.7 on inverse functions, and we have two vocab terms for you. The first one we have is one-to-one, and that says that for every value of x, there's only one y value. So no matter what x value you plug in, only one y value will come out, and that means the function's one-to-one. We also have the horizontal line test. So we've talked about the vertical line test, which proves a function is a function if it passes the vertical line test. And if a function passes the horizontal line test, it proves that the inverse is also a function. So some of our VICs, that the inverse of f of x is written as f and then -1 in the exponent of x. So this means the inverse of f of x. And that if you compose the two functions, if you have f inverse of x, it comes out to x. And if you have f inverse of f of x, it comes out to x. And by doing this, by composing the two, that's another way to prove they're one-to-one. You have to make sure that when you compose them, you're left with just an x value. Also, when we're talking about inverses, if you have a function f of x where you have the points -2, 1, -3, 8, -4, 17, -5, 23, when you find the inverses, the inverse of that function, your x's and y's switch. So instead of -2, 1, I'm going to have 1, -2. All my x's here became my y values here, and all my y values here became my x's here. So your points flip when you find the inverse of a function. So my first example says find f inverse of x. And so my function f of x is 2x plus 3. The first step you want to do is to replace f of x with y. So instead of writing f of x equals 2x plus 3, I'm going to write y equals 2x plus 3. And then I want to switch my x's and y's. So switching my x's and y's, I have x equals 2y plus 3.
You would switch all your x's and y's if there were multiple x's and y's.
And then I'm going to go ahead and solve for y. So I'm going to subtract 3 from both sides and then divide by 2. So I have x minus 3 over 2 equals y. And my last step is to replace y with f inverse. So I have f inverse of x equals x minus 3 over 2. So this is my inverse function to this. Now on my next slide, we're going to prove that they're inverses and prove they're one-to-one. So I have proved f of x and f inverse of x are one-to-one. So if I'm composing, I have f inverse of x, f of f inverse of x. So I have 2 times x minus 3 over 2 plus 3, because I'm plugging in my inverse function for x in my f equation.
So that's the inverse function to the original function.
So here, my 2 over 2, these will cancel out, and I have x minus 3 plus 3. And those will cancel out, and I'm just left with x, which is what I want, so that's good. Then I'm going to do the opposite also. I have f inverse of f of x. So I want to take my f of x equation and plug it in for x in the inverse. So I have 2x plus 3 minus 3 over 2. And here, this plus 3 and this minus 3 cancel out, so I have 2x over 2, and my 2 over 2 reduces to 1, so I'm left with just x again. And that's good because that's what I want. So that proves that they're one-to-one, and it proves they're inverses.